students reach out to me because they said that they needed some extra help on some of the content from week 1. So we're going to go over some of that, but we're also going to dive into some of the stuff that I've asked you to look at for week 2, okay? I've got some examples written down, and I'm just going to work them out here. I ask that you go ahead and mute your mic for me, so that as we are working through these, if you have a question, just type it in the chat, and I will either acknowledge you and ask you to unmute your mic or answer your question from the chat, okay? So hopefully everybody can see what I'm doing here. I have some different options for markers that I'm going to try out. I know my skinny blue marker does not work out very well.
Mr. Sorrells,
yeah.
This is Miss Hunter. Can I make a suggestion that you ask everybody in your class to mute their mics? Because I think what we have happening is a bit of an echo, and you're recording this for folks. So if they want to talk, unmute their mic, but it's not, they're picking up a voice of you, picking up a voice of them on their computer, and it's echoing back and forth.
Okay, got it. So if everybody could mute their mics, it looks as though everybody is muted. Am I still echoing? Okay. Now, I'm just going to draw a picture of a parabola, because a parabola is the shape of our quadratic function, okay? And our parabolas are in the shape of a U, right? Okay, so when we look at a parabola on the graph, we can now start to determine some really important features about the parabola. So this parabola here, it opens up because the U opens up, right? It's like we draw a U. So that means that this parabola has a vertex that is a minimum because it's the lowest point here, okay? Now, can you give me a thumbs up if you can see the writing in red for vertex and minimum? Okay, I was worried about the color. So what we're going to really focus on today is identifying how to mathematically find the value of the vertex, all right? Are we ready to move on? So it's being recorded, so if you need to go back and watch this stuff, you can certainly do so. And I know that you just want to go back and see me because you missed me so much, okay?
Aaliyah, turn your mic off.
Hi, Aaliyah. Hi, Danae.
Hi, and it was no, turn it off.
Welcome to the class.
I missed you.
I missed you both.
Mrs.
If you would, please,
can y'all please be quiet?
Go ahead and mute your mics.
Nobody want to say that. Mute your mic.
Ladies, go ahead and mute your mics for me, please, so we can keep going, okay? Danae and Aaliyah, if you have a question.
Get away. No.
Danae, will you mute your mic for me, please?
Oh.
Thank you. Michaela, you too. Thank you. Now, if y'all have questions, just put them in the chat for me, okay? All right, let's take a look at an example. We have y equals x squared minus 6x plus 5. Now, part of one of the things that you are doing this week is you are asked to find what's called the axis of symmetry, okay? And with that axis of symmetry, we have a formula that we'll use every single time, okay? Axis of symmetry. That formula, x equals negative b over 2a, okay? I'm gonna give you a moment to write that down. Negative b over 2a. Let me tell you first, before we start using the actual formula, let me tell you what the axis of symmetry is, okay? Can you all see if I draw down here, or is that too low? Give me a thumbs up if you can see.
It's too low.
Okay. I'm going to bring it up right here. Now, when we draw our X and Y axis, and we draw a parabola in, okay? Our axis of symmetry, if you've already watched the videos, you'll know this. Our axis of symmetry cuts the parabola in half. Whoop. Because it makes it symmetrical, right? Axis of symmetrical. You get it? Get it? Good. Okay, great. So what we're going to do, this formula will show us the equation for that red line. It's that simple, okay? So let's do it. Again, we're using negative b over 2a. Now, in order for us to use this, we have to recall some of the things that we learned when we were talking about standard form of a quadratic, okay? So remember, for standard form of a quadratic, it's ax squared plus bx plus c. So our a value is in front of that quadratic term, or x squared. The b value is in front of our linear term, or the x, and our c value is that constant that's over there by itself, okay? We're good so far? All right, so now let's actually use the formula to figure out what that axis of symmetry is, what the equation is. From this example here, our a value equals 1. There's no number listed there, so a equals 1, okay? I'm gonna write that over here, a equals 1. And then our b value is in front of our x term, so b equals negative 6, right? And our c value is that constant. So at the end, it equals 5. Okay? Again, if you have questions about where we are right now, just go ahead and type the question in the chat box or ask me to pause for just a moment, okay? So now that we've identified these 3 values, which we should have been able to do from before we left to be on our break, let's use those 3 values to substitute into negative b over 2a. Now this negative in front of my b term just means we use the opposite sign. Here, my b is already negative. So when I substitute it into the formula, it's going to become positive. What? Yes. So equals 6 over 2 times my a value. My a value is 1. So that is 2 times 1. Okay? Now, what is 2 times 1? 2. So we have 6 divided by 2. And what is 6 divided by 2? 3. So y'all guess what? Yep, if you said it, your axis of symmetry is x equals 3. Great job. Okay, are there any questions on that so far? No? Kay, do you have a question?
No.
Okay. All right. So let me tell you something. I'm going to give you a little secret that some of you may not is this on the notes that are posted? Aaliyah, you can unmute your mic.
Yeah, I wanted to know if it was on.
Yes, this is on the 8B notes. Your notes on 8B.
On the second side?
On the front side for axis of symmetry.
Uh-huh.
This should be on the first page.
Okay.
Okay. It also has this formula on the front page of your notes for 8B there. All right.
Okay.
Okay. So now that we have found the value for this axis of symmetry, guess what? We've already found half of the value for the vertex. What? Yes, that is true, because this x value is the same x value for the vertex. Okay, so you're already halfway there. All right, I'm going to erase this, but remember that x equals 3. Okay. Now, in order for us to find the vertex, are we okay with the blue marker? Thumbs up or thumbs down? I should go back to black. Okay. All right, thanks. We're going to use the black marker though, because everybody can see that pretty well. Now, for our vertex, we are going to use the value of x equals 3. Okay, and remember your vertex is the highest point or the lowest point on your parabola. Now, if I want to determine the y value for the coordinate of my vertex, we're going to use this x value and substitute it or put it back in to the equation here, wherever we see an x. Here, x equals 3. Since we know that, we could put 3 here, and we could put 3 here. And when we do that, we just have numbers on the right side, and we can evaluate. All right, let's do it. So y equals x squared, so that's 3 squared minus 6x, so that's 6 times 3 plus 5. Got to keep that plus 5 on the end, okay? Now, you just evaluate. You all can square stuff and multiply and add and subtract like bosses, okay? So 3 squared is 9. Negative 6 times 3 is negative 18. And I'm just going to bring down my plus 5 there. Plus 5. Now you just add or subtract, moving from left to right, okay? Just like you read, which I hope most of us have been doing while we've been out, all right? So 9 minus 18 is negative 9, and negative 9 plus 5 is negative 4. So our y value is negative 4. Yo, we have two values, x, y. When you put those together, they create a coordinate. And guess what that coordinate is? The vertex. Now, so I'm going to erase this up here. I know my x equals 3 and my y is negative 4. So my vertex is at 3, negative 4. Boom, mic drop, you're done. You have found the axis of symmetry and you have found the vertex. Now, are there any questions before we go on to another example? Thank you, Mrs. Hunter. Okay, we're going to do another example. But first, before I erase this, I want you to notice that our a value was a positive 1, yes? And in week 1, we identified if parabolas, those U-shaped things, if they opened up or down, if they had a minimum or a maximum. I'm going to tell you that this parabola, it's going to open up, okay? It's going to open up. And that means there is a minimum. This vertex is a minimum. Whenever a is greater than 1, it opens up. Now, we're going to see an example where a is not greater than 1, okay? Did I say negative 1? I'm not sure. I don't remember, okay? Anyways, let's find another example. We have y equals negative x squared minus 4x minus 3. Okay? I'll give you a moment. All right, let's identify the a, the b, and the c value from our standard form of our quadratic formula. Remember, a is in front of your x squared term, so a equals negative 1. What? There's not a 1 listed. You're right. If there's not a number listed, it's automatically assumed to be 1, so that negative goes in front. Negative 1. We also know that b is in front of our linear term, or the x. So that's a -4. Got to take the negative with it. -4. And our c is that lonesome number all the way at the end with no variables, -3. So c equals -3. Now notice that we don't use the c value when we are identifying the axis of symmetry or the vertex, right? Keep that in mind, okay? Now, I'm going to write up the formula for our axis of symmetry again. And that is x equals -b over 2a. Now I have a question for you all before we move on. Why is it that I should find the value for my axis of symmetry before I try to find the value of the vertex? Again, think about it, and then I want somebody to unmute their mic to answer. Why should I find the value for my axis of symmetry before I try to find the vertex? Anybody?
Mrs. Sorrells, I got a question.
Is you waiting for somebody to answer or like?
So I'll get to Michaela first. I'll get to Michaela first, and then we'll get to Danae, and then to Aaliyah. So yes,
no,
Michaela.
I got a question. I was just asking which way somebody to answer. I didn't think nobody was going to.
Okay.
I'm okay, kind of confused. What is that on the paper?
Hang on just a moment, Aaliyah.
Okay.
Michaela.
Yeah, I lost on that too, Aaliyah. But so does the what did you say, the whatever value, does that help you find the vertex or something?
Are you saying that the axis of symmetry helps us find the vertex?
That's a question, but yeah.
You're asking me that?
Yeah.
What do you think?
I don't know.
Well, yes or no? You have a 50-50 chance.
Yes.
Yes, it does. Yeah, Michaela. All right, so yes. You can go ahead and mute your mic again. We do find the axis of symmetry first because that x value helps us find the value for our vertex, okay? Aaliyah, I am just doing random examples, so these may not be on the notes.
Okay.
There's a video of me working out the problems on the notes in week 2 module. So that's why I chose different examples, because that's already up there. Okay?
Oh, it is?
Mm-hmm.
I don't see that. Okay.
Okay. Now let's take a look. Thank you, Mr. Chico. We're going to use this. Thank you. We're going to use this formula again for us to find the axis of symmetry. And just like Michaela said, once we've determined that value for x, we're going to plug it back in to help us determine the vertex of our parabola. Okay? So let's substitute it. A -b, here we have -4. This is different. I'm going to show you it this time. So a -4 divided by 2 times a, and a is -1. So 2 times -1, okay? Now notice there's a negative and a negative here next to the 4. A negative times a negative becomes a positive. So this becomes a +4 divided by, and then 2 times -1 is -2. So I'll put -2 in the denominator. Okay? Now we just divide. 4 divided by -2 is -2. That means our axis of symmetry is the line x equals -2. Okay? So I need you to pay attention to exactly what I just said. The axis of symmetry is the line x equals -2. It's actually a line on the graph, okay? It's a line that goes straight through the vertex, all right? This is not a coordinate, it's a line, all right? Now, we're gonna use this value of x to substitute back into our quadratic formula, or excuse me, our quadratic equation. and solve for y to find the vertex, okay? I'm going to erase these values here. We know the axis of symmetry, x equals 2. So when I substitute that value of x into my function, a negative, that comes first. My x is negative 2. Negative 2 squared minus 4 times x, and x is negative 2, and then minus 3. Now, just like the example before this, we evaluate, okay? We're going to go through this, reading it from left to right, using our order of operations to evaluate for y. Inside the parentheses is a negative 2. So a negative 2 squared, that becomes a positive 4, correct? But then there's a negative on the outside, so we have to keep that. A negative, positive 4. This positive 4 came from negative 2 squared, okay? Negative 4 times negative 2 is a positive 8. So we'll write plus 8. And then bring down your lonesome negative 3, minus 3. Now we just read it from left to right, add or subtract. Negative 4 plus 8, it's a positive 4. And then 4 minus 3 is 1. So y equals 1. Well, we got an x value, we got a y value. We now got a vertex. Our vertex, ladies, is at the coordinate negative 2, positive 1. Okay? So ladies, do you have any questions on determining the axis of symmetry or the vertex so far?
On the vertex thing, I get it, but I don't get it.
Okay. Do you understand then how we found the axis of symmetry, the value for x?
I know that.
Okay. So all we do from here, Michaela, is take that value, and then you're going to put that value of x into the actual equation wherever you see an x variable. And from there, you evaluate. Okay?
Oh, okay. It looked complicated, but like once you break it down, it's not complicated.
Okay. Leah, do you have a question?
No, I was gonna. Are you gonna go over like how to do the whole thing plus graph it?
I'm not going to graph it here right now. Okay, because graphing it, I would need a coordinate plane, and I don't have one of those here with me right now.
Okay.
Do you have a specific question on graphing it?
Like, I was just seeing, like, I just wanted an example on how you would do it after you got your answer.
Okay, so what I can do, I can graph the axis of symmetry, and I can graph the vertex for us. And I will also throw in here real quick the y-intercept. Because the y-intercept for any type of function is always where x equals 0. So that's the same with linear functions, which we've already gone over. Okay, so let's do that with this really quick, and then I'll move on to another example. Does that sound okay?
Okay.
All right. So I'm going to graph my axis of symmetry, x equals negative 2, and my vertex here, okay? Now, it might not be real pretty, okay? So we have 1, 2, 3, 4. I did an x-axis and a y-axis with positive and negative 4. All right, let's make sure all of our mics are muted. So I'm going to first graph the axis of symmetry, x equals negative 2. Now, remember that with x equals, This is a vertical line. It means it goes up and down, okay? It is parallel to the y-axis, and it's going to go through the point -2. So here's my x-axis. I'm going to go to -2 on my x-axis, and we'll draw a vertical line through that. I'm going to make it dotted because that line is not actually part of the parabola, okay? That just shows us where it's cut in half. Now my vertex is at the coordinate -2, +1. So I'll go to -2 on my x and go up to +1 on my y. And I can plot a point there. And that point is my vertex. So I will label it vertex. Okay. Now, from here, we really should be able to just draw a sketch of what the graph looks like. Looking at, because I know it's a U, but looking at my A value is negative. So that means this graph has to open down, okay? Since I already have plotted the vertex and I know it opens down, just like that, and you have your graph, okay? Those are two really important pieces that are easy to pick up on just by doing a little bit of math to determine the coordinate for your vertex and just identifying that A value, okay? Does that answer your question, Aaliyah?
Yes.
Okay. So I'm going to try one more example, and after that, I'll open it up to other questions before we end our session, okay? Does anybody have a question on this specific example before we move on? Okay.
That's me. There's no eating in class. So put it up. Thank you. Exactly.
There's also no talking in class.
All right, thank you for your enthusiasm and your support. I really appreciate you. Let's do that one. We have y equals x squared plus 2x. Y equals x squared plus 2x. This one looks a little different than what we had before. Notice it's still in standard form. We have an x squared term, which you have to have for a quadratic equation. So x squared, we still have a linear term. We have x, but we don't have a c value. Do you think that's going to affect our axis of symmetry? Nope. Why not, Destiny?
Well, we don't really use the C value in any way, so there really is no use for it.
Good job. We will not use. Thank you, Michaela. We will not use the c value to determine the axis of symmetry or the vertex in this problem. Okay, so good job. Let's find the axis of symmetry first. Remember, x equals -b divided by 2a. I'm not going to write out the a and the b value, okay? So in -b, that's the opposite value. Our b here is 2, correct? It's in front of our linear term. So -2 divided by 2 times our a value. And a is in front of our quadratic term, or the x squared. So that's a 1, okay? So now we'll just evaluate. -2 divided by 2 times 1, which is 2. What is -2 divided by 2? 1.
1.
-1, right? Ooh. I almost got you. I almost got myself. Okay, -1. We have an axis of symmetry, x equals -1. Okay? I usually abbreviate A of symmetry, axis of symmetry, because math people like to abbreviate. We don't always like to have to write everything out, just saying. So now that we have that value, I'm going to go ahead and erase this, okay? Remember, x equals -1. I'll rewrite that in just a minute. I just want more room to work this out. Axis of symmetry, x equals -1. Now remember, we just take that -1 and we substitute it back into x right there and evaluate, find our vertex. I'm going to go ahead and write the word vertex out. And go ahead and identify the x value of -1. Boom, boom. So now I just have to fill this in, okay? Let's do it. So y equals -1 squared plus 2 times -1. Oh, that doesn't look like a plus. Okay. Let's evaluate. -1 squared is +1, yo. Okay. So y equals 1. And then 2 times -1 is a -2. So now you have 1 minus 2. 1 minus 2 equals -1. Oh my goodness, yo. Our x and our y value are the same. Oh, that's so cool. All right. So, yes, Kay.
I forgot to tell you, I got 100 on my test today.
I did too.
Why are you yelling? He's right
Good
there.
job. Yeah, I'm very proud of you. So, ladies, I hope that this live session has helped you with the axis of symmetry and determining the values for your vertex. Also remember that your A value, the number that's in front of your X, helps you determine which direction it opens. So if A is positive, it opens up. If A is negative, it opens down. And those two pieces also indicate whether you have a minimum or a maximum to your parabola, okay? What I'm gonna do is create an anchor chart with some of this really important information on it, and I'll post it to Canvas by the end of the week, okay? So I'm giving myself until Friday morning to post that anchor chart for you all. Just look for it in the prep work, okay? I will probably post it in an announcement as well so that everybody else that decided to not come to my live session today can have this information. What's that?
You should have told them it was for a grade, and maybe they would have came.
Oh, well, I really appreciate you coming. Does anybody have any questions for me? Okay.
What about the
If you
C-note?
do have a question, remember to type it into the chat box and I can tell you to unmute your mic, okay?
What about the C notes?
I like them nasty. Aaron, shut up.
Okay.
That was Aaron.
Ladies, let's
Mic.
mute our mics, please.
Mr. Mills, I had a question. What about
Okay, yes, Leah.
note C?
What about them?
Are you gonna go over them, or are we?
Not today. The session was until 5:15. If you need me to go over those, I can do a quick intro to them, but I also have another video posted to Canvas about those notes particularly, okay?
Okay.
Does anybody have any questions specifically about the axis of symmetry or about the vertex of a quadratic?
Easy. It's kind of easy.
Okay, well, if there are no more questions about those two things, I will touch on some of the notes from 8C. Those notes have us identifying the domain and the range of a function, but also intervals about where these functions increase and decrease, okay? I want to particularly take a look at this example. I'll leave this function up here, x squared plus 2x, but really when we are identifying...
How did I get married?
What's that, Kate? Okay. When we are identifying increasing and decreasing intervals...
Cambria, we're so mute.
Okay, that's my, thank you. When we are identifying those intervals, we really want to take a look at the graph itself, okay? So remember our axis of symmetry and our vertex. I'm going to use those two to help me graph this. Woo! So you can have the graph up. Now I'm going to focus on the increasing and decreasing intervals for the next 8 minutes because I think that can be the more challenging piece between this, okay? Our axis of symmetry is at x equals -1. So that could be about right there. And our vertex is at -1, -1, which would be about right here. And it opens up because my a value is positive. Okay? Now, what you're going to notice is that with quadratic equations, our domain is all real numbers. It's all real numbers. That's your domain all the time. Okay? I'm going to write domain, all real numbers. Now, here's where we're going to use some of the values that we have found with our axis of symmetry and our vertex, okay? Specifically where we see values for increasing and decreasing intervals. So that just has us following the graph of the parabola. We read graphs from left to right, just like we read a book, okay? And if I were to start here and I were to follow the graph, I'm going down first, okay? So going down means it's decreasing, all right? So when we're talking about increasing and decreasing intervals, this first blue line here would be a decreasing interval. I'm going to write decrease because it goes down. Now, when we're talking about intervals themselves, we only use the x values. Okay? We're only talking about the x values. So do we really know what x value this graph stops at if it were to keep going in this direction? No, we don't. So what's the biggest number that you can think of? If you said infinity, you are correct. 2 thumbs up. So our x-axis can extend in both directions forever. So when we're talking about intervals, we use negative infinity and positive infinity to identify where they don't end, okay? So our decreasing interval starts from negative infinity because we don't know where it stops, right? And it'll keep coming down. But notice at the vertex, it turns upward, right? And it starts increasing here. So that axis of symmetry really splits the graph into a decreasing piece and an increasing piece, okay? So our function decreases from negative infinity to this x value of -1 because it's going down until it gets to this x value of -1. And then what does it start doing? It starts going up, so it starts increasing, right? So that means it increases from -1 and it keeps going. So it increases until infinity, all right? So that's how we identify the decreasing and increasing value. Now, I'll tell you that if this graph opened down, your decreasing and increasing would flip, okay? I'll show you that in just a moment. I'll give you a second to kind of take all of this in, and I'll draw you a new graph to show you the difference. But also remember that the notes are on Canvas, and there's a video of me going over those notes too, okay? So I'm going to keep that graph there because that graph opens up. I'm going to erase this equation. Okay. This graph on the right, it opens up. If my graph opened down, I'm going to show you like that. Okay. Notice I still have an axis of symmetry that cuts that graph in half. Okay. Now, if we go back to my statement that we read graphs from left to right, starting on the left, I'm actually going up first. So that interval would be the increasing interval. Okay? And then once I get to the vertex, it's going to turn. It's going to start going down. So that one would be my decreasing interval. Okay? Increasing means when it goes up. Decreasing means when it goes down. Notice the difference that if a graph opens down, whoops, I wrote decrease and I should have wrote increase. My B. There we go, fixed. If the graph opens down, it's going to increase before it decreases. This is a good segue into next week's lesson where we look at the shape of objects that could be thrown. Hint, hint. Okay? This graph that opens up goes down first or decreases first, and then it goes back up. That turning point is always your vertex. Okay? So Aaliyah, that is a little bit of an intro into those intervals for increasing and decreasing. I hope that was helpful. And if not, you can just reach back out to me after you watch the rest of those videos that are on Canvas. Does anybody else have any questions?
I don't think they got questions. So nobody got questions.
Okay. Okay. Well, thank you, ladies, for joining me today. I do want to encourage you, to continue to just doing your work in Canvas. You all are doing amazing, and I'm really proud of you. I miss seeing you all, so this is really, really cool to be able to do this. Also, make sure that you check your announcement on Sunday that has really important information for next week's content, okay? Make sure you read the whole announcement. Read all of it, all the way to the bottom. You'll be glad you did, okay?
I actually do have a question.
All right, let's go to Kay Brianna first. Yes, Kay?